Assalamu alaikum warahmatullahi wabarakatuh, students. Right, we were discussing Laplace transform last time, so let's continue inverse Laplace transform. Today, we are going to discuss some cases. For example, Laplace inverse of 1 over s into s plus 2. If we look into our formula sheet, so there is no formula that covers this part of the situation. So if we look into the formula sheet, s into s plus 1, there is no formula that covers s into s plus 1. There is one s minus a, but not s into multiplied with s minus a. So we do not have any direct formula for this one. What we cannot do, so for example, if I would write Laplace inverse of 1 over s and multiplied Laplace inverse of 1 over s plus 2. This is very wrong actually. From the formula page, if we look at formula 32, look at this formula 32. Formula 32 says Laplace inverse of f of t multiplied g of t is not equal to Laplace inverse of f of t multiply Laplace inverse of g of t. We cannot separate when there is a multiplication between the functions. So that's the problem. This is not possible. So what else is possible? Can I write, for example, 1 over s, take 1 over s outside and write 1 over s plus 2? Again, this is not possible because 1 over s is a variable. It cannot go outside. It cannot go outside the inverse. So what we do here is a technique which we call partial fractions. So we use partial fractions. There are four kinds of partial fractions. So let's list the partial fractions here. Let's say if we have a function like 1 over s into s plus 2, like the one we have above, a over s plus b over s plus 2, because s and s plus 2 both are linear. Okay, so a over s and b over s plus 2. Let's say if we have s minus 2 over s square, or let's suppose s minus 3 square s plus 4. Now the first one, s minus 3, is linear, but there is a power on s minus 3, so we write it two times, first without the power and then with the power, but still the constants are only the one constant, a, b, and c. So s minus 3 square, first we write s minus 3 without square, then b over a new constant, s minus 3 square, plus c over next s plus 4. As you can easily observe that s minus 2 does not participate when we write this step. Okay, it will participate later. We will use s minus 2, but later. Let's say we have 3s plus 4, 3s plus 4 over s plus 6, s square plus 2. Now we have a quadratic here. So a over s plus 6, because s plus 6 is linear, plus bs plus c over s square plus 2. As you can see that s square plus 2 is quadratic. So the choice of constants for quadratic is bs plus c, the linear. Okay? Similarly, would be the case for two quadratics. If we get in case, let's say if we have um, s over s square plus 1, s square plus 6, so that would be as plus b over s square plus 1 plus cs plus d over s square plus. Do not repeat the constant a, b, c, and d. Okay, s is our variable, but a, b, c, d are the constants. So these are the four possibilities which we might come across. There are there is another possibility that there is a quadratic with the square, but I won't discuss that because we possibly won't get that situation. Right. So now the next question is how to find A, B, C, all these constants. So let's start with first example, the linear with the linear. So let's say 1 over S into S plus 2 equals A over S plus B over S plus 2. Right. So we multiply both sides with S into S plus 2. What do we get? We get, when we multiply S plus 2 here, 1 over S plus 2, S plus 2 A over S plus S plus 2 B over S plus 2. This whole thing cancels, and we get only 1 here, and here S is cancelled, and we get A into S plus 2. Here S plus 2 is cancelled, and we get B into S. Right. So as a first step, we multiply on both sides. We multiply this thing. Okay? This thing we multiply. This thing. Okay? This thing we multiply here. We multiply it here and here and here. Okay? Let's use this question mark so that it doesn't confuse you later. Right. So now we have this equation. Now we put S equals 0. Okay, one by one. This first one equals 0, S equals 0. This one, S equals 0. That gives 1 equals A times 0 plus 2 plus B times 0. So B goes away, and we get 1 equals 2A. Let's squeeze the equation a little bit, save some space. And that means A equals 1 by 2. Now we put second one. There are two terms here. One is S and the other is S plus 2. Okay, two terms, S and S plus 2. So first we put S equals 0. That gives us A. Now we put S plus 2 equals 0. That means S equals minus 2 here. Okay, we put it here. Okay? So that gives 1 equals A times S is minus 2. So minus 2 plus 2. B times minus 2, that implies minus 2B, and that implies B equals minus 1 by 2. So now we have A, now we have B, so it means our partial fraction is ready. S into S plus 2, 1 by 2 over S plus minus 1 by 2 over S plus 2. Now that's good. Okay? So that's how we make partial fractions. Now let's see, why do we need partial fractions? Now let's complete our question. So we started with, if we have to find Laplace inverse of something like this. Okay. So what do we do if we have to find Laplace inverse of something like this? I will start with another question, just for it will add into our practice. So Laplace inverse of S over S square plus 2s minus 3. As you can see again, that our formula sheet does not answer this question directly. S square plus 2s minus 3. There are three terms here. There is an S square, but two more terms. Our formula sheet has formulas with S square, but only two terms, S square plus constant, S square plus constant, S square minus constant, not like s square plus s term and a constant. Okay, so none of these four formulas we can apply directly. If we can, we will try to factorize first. Okay, so can we factorize? Is like this: s plus 3, s minus 1. Now these are two linear terms, just like our previous example, this one. Okay, so now we can write the partial fractions. S over s minus 3 into s plus 1 equals a over s minus 3 b over s plus 1. Note again that this s has no contribution when we write this step. No contribution when we write this. We only look at s minus 3. We are looking at s minus 3 and s plus 1. We are looking at these two to write this first step. Now we multiply on both sides. Multiply s minus 3, s plus 1 on both sides. So what do we get? So s minus 3, s plus 1, s over equals, right. So this side gives s because this whole thing cancels here. S minus 3 cancels here. S plus 1 cancels here. So we get s equals a times s plus 1 and b times s minus 3. Right. Now we put s plus 1 or any one, s minus 3, let's say, because that's written first. So put s minus 3 equals 0. This implies s equals 3. So 3 we put here. Okay, s equals 3. So this becomes 3 equals a times 3 plus 1 plus b times 3 minus 3. As you can clearly see, b goes to 0 because 0 into b is 0 and a 4. So that gives a equals 3 over 4. Now again here we put second term, which is s plus 1 equal to 0. That gives the value s equals minus 1. So minus 1 on this side here, minus 1 equals a times minus 1 plus 1 here, s equals minus 1, b times here s equals minus 1, minus 1 minus 3. That gives minus 1, and I'll write it in the same line. That gives minus 1 equals b times minus 4, so b equals 1 by 4. So our question, Laplace inverse of s over s square minus plus 2s minus 3 becomes Laplace inverse of a over, which is 3 by 4. Yes, of course, we can write this middle step just to complete the reason. S over s minus 3, s plus 1. And from here we write Laplace inverse of a over 3 by 4 over s minus 3, 1 by 4 over s plus 1. Now we know that Laplace inverse can be separated over addition. It cannot be separated over multiplication. It cannot be separated over multiplication, but it can be separated over addition, just like Laplace, just like Laplace. So inverse can also be separated over addition or subtraction. So we can make two inverses. So Laplace inverse of 3 by 4 over s minus 3 plus Laplace inverse of 1 by 4 over s plus 1. This is now very easy. 3 by 4 is a constant. It can go outside. Why not do this in the same step to save some time and space? So 3 by 4. Laplace inverse of 1 over s minus 3. So which formula is it? Laplace inverse of 1 over s minus 3. This formula here. 1 over s minus a. A is 3, so it becomes e power 3t. So e power 3t plus 1 by 4 e power minus t. So which formula we used? We used Laplace inverse of 1 over s minus a equals e power at. So if a is 3, so it becomes e power 3t. Yes, note please that this is plus 1, plus 1. So that's why, because of this minus, this is minus t, because here a equals minus 1. Okay? So that's why e power minus t. Right. So that completes our Laplace inverse of s over s square plus 2s minus 3. First we vectorize, and then we do partial fractions, separate up into two linear fractions, and then of course we have to find a and b, which we do using partial fraction techniques. And then once they are separate, put the values here, split the Laplace over addition, inverse over addition, and use the formula. Right. Let's try one more question. This time we will try one linear and one quadratic. For example, Laplace inverse of s over s plus 2 s square plus 4. This is factorized already. It is already in the product form. So first we write s plus 2 s square plus 4. It is a second type, if you remember, third type rather, this type. So it is this type. Some function over linear into quadratic. So linear goes with a over, and the quadratic goes with bs plus c over. So we write equals a over linear plus quadratic bs plus c over s square plus 4. First step is exactly the same. Multiply both sides with s plus 2 and s square plus 4. All right, pause the video here and see if you can do the step. Multiply both sides with s plus 2 s square plus 4. Pause the video. All right, let's see if you have done it correctly. S plus 2 s square right. On the left side, we are only left with s as usual, and on the right side, a times s square plus 4 bs plus c times s plus 2, because s square plus 4 is cancelled here. All right, now what next? We have one linear term. We have one linear term. S plus 2 is our linear term. So what we will do is we'll put it equal to 0. So put s plus 2 equals 0. That gives s equals minus 2. So minus 2 here, minus 2 equals a times minus 2 square, which will be plus 4. Okay? Minus 2 square. This one, minus 2 square, that is plus 4, plus bs plus c s is minus 2 plus 2. This will go to 0. And now we get minus 2 equals a times 8. Oops, not b. A times 8. And that means a equals minus 2 by 8. Or in other words, minus 1. Right. Now, how do we find b and c from here? How do we find b and c from here? The technique we use, we have already used that technique actually. What we do is we can write it again, a s square plus 4a plus bs square. Just open the brackets, all of them. Bs square plus 2b. Let's drag it a little bit down. Bs square, oops, sorry, bs square plus 2bs plus cs plus 2c. Let's multiply everything. So bs multiplies here, then bs multiplies here, then c multiplies here, and then c multiplies here. 4 terms. Okay? Right. Now we compare coefficients. Compare coefficients. We can start with s square. So first start with compare s square. 0. This side no s square, so it's 0. On the right side a and plus b. Then we compare s. On the left side we have 1, the coefficient only, coefficient of s, which is 1. Okay, not s, just the coefficient. On the right side, not s, not s. This one is s, so this is coefficient. 2, 2b is the coefficient. So we write 2b, and here again plus c. Now we compare constants without s, the terms without s. This one is without s, okay? This one without s, and this one is without s. So on this side, no constant term, 0. On this side, 4a plus 2c. Now we have three equations in three unknowns, but actually we already know one, a. A we already know. So that will help us a great deal. This implies b equals minus a. That means b equals plus 1 by 4 because a is minus 1 by 4. And this implies minus 4a. Let's write it the correct way. 2c equals minus 4a, or in other words, c equals minus 2a, or that implies c equals minus 2 multiplied minus 1 by 4 because we already know a from here. So this implies c equals 1 by 2. Okay? Now we didn't need this one, so it's okay. It's okay. We did not use this equation, but that's fine. We know a, b, and c. That's all we wanted. Now we go back to our this relation and put a here, b here, and c here. So let's see what do we get. So we write s over s plus 2 s square plus 4 equals a over, so that is minus 1 by 4 over s plus 2 plus bs plus c. So 1 by 4s plus 1 by 2 over s square plus 4. Actually, we wanted Laplace inverse of this thing, s plus 2 s square plus 4. So that means we need Laplace inverse of minus 1 by 4 and 1 by 4s. This thing. Now the right hand side, there are two inverses. This first one is very simple. Minus 1 by 4 Laplace inverse of 1 over s plus 2. And the second one we have to split again. We have to, because we can split numerator, so we split again. Let me make some space for it. So that will become Laplace inverse of 1 by 4s over s squared plus 4 plus Laplace inverse of 1 by 2 over s squared plus 4. What do we use here is we can easily write, we can a plus b over c plus d is equal to a over c plus d, b over c plus d. That's very possible. Right. So this one, first one is minus 1 by 4 e power minus 2t, using the same formula which we used in the last question, plus 1 by 4 Laplace inverse of s over s squared plus 4. Note that this s cannot go outside because s is a variable. Okay, only 1 by 4 can go outside. And last one is plus 1 by 2 Laplace inverse of 1 over s squared plus 4. So which formula helps us with s over s squared plus 4? S over s squared plus 4. So that is cos kt. And 1 over s squared plus 4 is sine kt. So we use these two formulas here. And we get minus 1 by 4 e raised power minus 2t plus 1 by 4 into, no need to write into, cos 2t plus 1 by 2, another 1 by 2 sine 2t. Why did I write this 1 by 2? Can you guess? There is 1 by 2 already. Why did I write this 1 by 2 here? Make a good guess. Because there is 1 over k. In the case of sine formula, whatever is over here, k, we also write 1 over k outside. So 2, our k is 2 here. K is 2. So that's why 1 over 2 sine 2t. Okay? So that's why there is an extra 1 over 2 here. If you want, you can write it one more time. Plus 1 by 4 cos 2t and plus 1 by 4 sine 2t.